Another feature we've got in C++, classes. Now, it's the basis of object-oriented programming, and people see classes and see all the objects and they think, oh, here's lots of overhead that come along. They are essentially enhanced versions of structures. And now structures everybody's familiar with in C. They're used a lot of the time. And the basis of an object is we can create a whole new type in our program. But one of the really useful things about classes is that once they're set up, they become like a toolkit for the compiler, and they will allow us to automate the tasks that we would have done automatically. And people then say, well, oh, okay, automatically, that means the compiler's doing something that I wasn't expecting it to do. Well, maybe, but the compiler can be controlled. And the compiler can be told what to do in given situations. So you shouldn't feel that the compiler is running the show, and you don't have control. You do. You can generally override anything the compiler wants to do for you. So let's have a look. What's a structure in C? It's a collection of data. And you have different fields within that structure, and each field has a name and a type that's associated with it, and they come together as a group. So here we've got a simple structure with a couple of members. You could create a vector with X, Y, and Z parts. You can do all kinds of structures. And in C, we have that structure. It gets created. It's there in memory. And the problem with a general C-style structure is that in order to use even a part of that structure, you have to reveal the content of the whole thing. And so if somebody can see the whole of your structure, they can change and look at the members that you might not have wanted them to see. If you had some kind of encryption logic that you had going on, if you passed over a structure to your encryption routines, you might reveal the keys that were used for the encryption as well, because they're just a part of the structure, and you can't stop somebody from seeing that. It's also normal that when you've got structures that you pass pointers around, pointers to these structures. Now, we've talked about pointers already, and we've seen how we can use references to avoid the problems with pointers. But of course, as soon as I've got a pointer, I can do what I like to your structure. You've lost control, and you can't stop me from changing any of the members of that structure. Classes in C++ are very much like structures. And in fact, the only primary difference between the two is the default accessibility of the members, the items within that structure or class. In structures, everything's visible, everything's public. In a class, everything's private by default. And that's about it. But we generally use classes to represent objects, and that's how we're going to do the object-oriented code. Now, C++ added the idea of not just having data members in our structures or classes, but we can have functions that are tied to those classes as well. We can also have functions within structures that are associated with a given structure, but that's not quite so common. But a class has a set of functions that will work on the data in that class. So now we have one object that we have not just the data that's within that class, but we also got different operations that we can do on that data. There's a common myth that when we put functions into a class, that the code is stored in the class as well. It's not. The code is stored wherever code normally gets stored in your program, whether it be in Flash or in RAM or whatever. But the functions are created by the compiler in a way to only work with that an object of that type, of that particular class, and it allows a level of automation. And I keep saying that automation is something that's very attractive to programmers. One of the common mistakes you get in a program is forgetting to do something. At a simple level, if we're allocating memory, people often forget to free that memory, and we get memory leaks. There's lots of other tasks where people create an object and then forget to initialize it. I've seen people write code where they write a beautiful code for initializing a piece of hardware and then forget to call it. Wouldn't it be so much easier if the code automatically could do the initialization function and the tidy up afterwards? And that's what C++ and its classes will do for you.
Doulos is a training company providing expertise and specialist training worldwide in all of the areas you can see on screen, from SoC design and verification, FPGA and hardware design, to embedded software and Python and deep learning. You can watch the rest of Des's webinar, Embedded C++, Dispelling Myths and Preconceptions, whenever you want, by heading over to our website www.doulos.com/od and registering for free. For more free tips and tutorials, visit the know-how area of our website, and don't forget to subscribe to our YouTube channel. Thanks for watching.